Given that we've now defined a function and we've identified how we can evaluate a function, we're going to talk about functions, relations, and something known as the vertical line test. So we said that a function was something that had an input, it went into the function box, and then it gave us an output. So this is our broad definition of a function. A function, the way that we'll use the word function, we tend to have one extra consideration that we want to addend onto what technically constitutes a function. And this is that each x input gives a unique f of x output. Now, what do I mean by this? Well, what this means is if you put an x value in, you get one. In this sense, we mean unique to be a single. For each x input, you get a single f of x out of the function. So there are some equations where you put a single number in and you get two numbers out. That is not a function, right? That's something else. So for something to be a function, we need each x input to give only one f of x output. So let's have a look at an example. We might think about y equals x squared plus, let's say, 2. And we might test if this is a function. So we want to know, does this actually constitute the definition of having each input giving a unique f of x output? Well, one way we could do this is we could say, okay, let's put a few values in and let's see if there are any values that we can work out that would give us two outputs. Well, maybe if x is equal to 0, 0 is an unusual value, we get y is 0 squared plus 2, that's 2. So this input gave us a single output. What about if x is maybe the square root of something, the square root of 10? Well, we'll find that y is the square root of 10 squared plus 2. Well, square root of 10 squared is 10, that's 10 plus 2, that's 12. So a single input gave us a single output. And you can do this all day, right? You can do endlessly many of these. And actually, you'll find that there's no input to this equation, no x input, which gives you multiple different y outputs. And consequently, y equals x squared plus 2, which we could write as f of x equals x squared plus 2, is a function. So when we say function, we mean something that takes an input and gives an output, but specifically each x input must give a unique f of x output. And when we say unique in this context, we mean that each x value that goes in gives one f of x value that comes out. One other way that we can show that something is a function is what's called the vertical line test. The vert line test. So the vert line test works as follows. You draw the function. I'll put function in little commas here because we're assuming it's a function at this point. So we draw it. So let's draw the thing that we had above. It was y equals x squared plus 2. So it passes through 2 here. It's parabola, goes up like this. So this is y, this is x. And then step 2 is you find a vertical line which cuts more than once. So we want to draw a bunch of vertical lines on this. So let's get our little ruler tool out. So we could draw a vertical line over here like this, could draw a vertical line here like this, maybe over here as well. That's enough of our ruler. Let's put that away. So we have a vertical line here, vertical line here, and a vertical line here. And you can draw endlessly many of these. Cuts once to this one, once to this one, once to this one. So for step 2, we're trying to find a vertical line which cuts more than once. Well, there aren't any, right? You could keep drawing tons of these, and you're not going to find anywhere it cuts more than once. So for step 3, essentially, if none are found, this implies that you're dealing with a function. And if at least one is found, you are dealing with something that is not a function. For the purposes of this course, if you are dealing with something that is not a function, usually we're going to give that the name relation. So the vertical line test shows that something is a function. Something which is not a function is also known as a relation. Relation is a much more general word for any expression combining combinations of, say, x's and y's, or f of x's and x's. So if none are found, it implies it's a function. If at least one line is found where you have two intersections, then it is not a function. So I'm going to get you to have a go at 2 questions for me. Question 1 and question 2. I want you to work out if these are functions or relations. And I'm going to give you some formulas. The key here will be to graph the formulas. So let's say we have x plus 2y equals 4. And then we might also have x squared plus y squared equals 9. Now, for the graphing step of this question, you can use computer-aided technology to do the graphs if you wish. Or if you want to try and graph them manually, you're free to. These are known shapes. Probably most of you have seen formulas for both of these graphs before. If you haven't, you can get a computer to graph both of them. So have a go now, work out if they're functions or relations. Good luck. Okay, so now that you've had a go at these, let's see what we can do. Well, the first one, if we graph this, we could rearrange it. We could minus x from both sides. We get 2y. So this gives us that 2y is equal to 4 minus x. Divide everything by 2. This gives us that y is 2 minus a half times x. Well, this is a diagonal line. So if we draw a little graph of this, its y-intercept is 2, its slope is minus a half. So if x is 4, half times 4 is 2, it'll cut over here at 4. So ruler tool, we're going to cut these lines through these 2 points. So it looks sort of like this. So it goes up here and then it goes down here. This is x and this is y. Always label your axes, so you might lose marks if you don't. So this, let's do our vert line test. Get our ruler. We can say, okay, vertical line here, maybe a vertical line here, vertical line over here. That's probably enough. So we have one intersection on this one here, one here, one here. And in fact, no matter how many of these lines we did, we would find that diagonal lines only have one intersection on each vertical line. So this actually is a function. This is a function. So question 2, this thing is a little bit more complicated. We could rearrange it for y equals. So minus x squared from both sides. This would give us y squared is equal to 9 minus x squared. Take the square root of both sides. This will give us 2 equations. Y equals the positive square root of 9 minus x squared. And the second one is y equals the negative square root of 9 minus x squared. So if we want to graph this, we'll draw a little graph. The first bit, the positive bit, we could plug some points in. If x is equal to 3, so if we let x equal 3, we find that y is equal to 9 minus square root of 9 minus 9, that's 0. So if x is 3 over here, this is 0. If x is 0, y is the square root of 9, which is 3. And then if x is minus 3 over here, y again becomes 0. And if you used your computer or you've seen this function before, x squared plus y squared equals 9 is actually the equation for a circle of radius 3 centered at the origin. So this is the positive square root part. Negative square root part is the base of this circle. So this is what this thing looks like if we graph it. Let's do the vert line test. Well, we don't have to draw many vertical lines, as it turns out. So we can draw sort of one here, and we can draw one here. We might be able to draw one over here as well. So that's enough for the ruler. This line just cuts once, but these two both cut twice. In our test, we said that if at least one is found that has more than one intersection, it's not a function, it's a relation. So that means for question 2, this is a relation. If I can spell relation right. relation. It's a relation, not a function.